Hello everyone, welcome to EnviroPioneers. Today we will start with a new topic, that is the Global Positioning System. For better understanding of GPS, this topic is divided into three parts: introduction, working principle, and then real-time kinematic and differential GPS. So today in this video we will cover this topic, introduction to GPS, and then working principle and the difference between real-time kinematic and the differential GPS will be covered in the subsequent videos. Having a smartphone has made our life easier for finding a new place or for navigating from one place to another. Nearly all of us are dependent on the Google Map. Google Map is a mobile application which is developed by the Google, which requires a connection to internet data, and normally it uses a GPS satellite connection to determine the location. Apart from Google Map, there are various other applications that we use in our daily life and they are dependent on the GPS. For example, when we try to book a ride on a ride booking app, the app shows us the nearest ride available as well as the time required to reach the destination. When we order the food or the grocery on the online platform, so we can track the movement of the delivery persons. So through all these apps, we are directly or indirectly using the GPS. In research or in scientific studies, use of the device, that is the GPS receiver, these are generally preferred for noting the latitude and longitude of the sampling locations. These devices are solely designed for the GPS applications and are having the better accuracy in comparison to the smartphones. So what is this GPS? GPS is one of the global navigation satellite system, that is also abbreviated as GNSS, and this is a general term which describes any satellite constellation that provides positioning, navigation and timing services on a global or a regional basis. And the GPS is the world's first and the best known GNSS constellation with widespread brand recognition, and it is also the most commonly used GNSS constellation, and nearly all the receiver and the antennas, they can track the GPS satellite. Therefore, many people all over the world, they use the term GPS when really they are referring to GNSS technology. Apart from GPS, we also have some other global navigation satellite systems. For example, GLONASS, it is owned and operated by Russia. BIDO, which is also abbreviated as BDS, this is owned and operated by China. Then we have the Galileo, which is owned and operated by the European Union. These four navigation satellite systems, they provide the global coverage, while these two, they provide the regional coverage. So here we have the QZSS, that is the quasi-zenith satellite system, which is owned and operated by Japan. Then we have the IRNSS, that is the Indian Regional Navigation Satellite System with the operational name NAVIC, that is the navigation with the Indian constellation. Now let us learn about the GPS in detail. So the GPS, or the Global Positioning System, is a navigation system using the satellites, a receiver, an algorithm to synchronize the location, velocity and the time. And this GPS is a US owned utility that provides the user with positioning, navigation and timing services. So this is referred as the PNT services. US Department of Defense, they launched their first navigation system with timing and ranging satellite in 1978. So this GPS was originally referred as the Navstar, which is having the full form navigation system with timing and ranging. So the first satellite was launched in the 1978 and the 24 satellite system became fully operational in 1993. So GPS is a multi-use space-based radio navigation system which is owned by the US government and is operated by the United States Air Force. And this system, it consists of three segments: the space segment, the control segment and the user segment. And the US Space Force, they develop, maintain and operate the space and the control segments. Now we will explore about these three segments of the GPS in detail one by one. So the first segment is the space segment, which consists of a constellation of the satellite transmitting the radio signals to the users. And these satellites are positioned in 6 orbital plane with 4 slots occupied by baseline satellite in each plane. And these orbits are nearly circular and equally spaced above the equator at 60 degrees separation from each other and having the inclination of 55 degrees relative to the equator. And these GPS satellites, they fly in the medium Earth orbit at the altitude of 20,200 kilometer. So what is this medium Earth orbit? This we have already covered in one of our previous videos. So you can refer to that video for understanding the difference between low Earth orbit, medium Earth orbit and the higher Earth orbit. So here in this case, in the GPS satellite constellation, the orbital period of the GPS satellite is 11 hours and 58 minutes, that is approximately 12 hours. Each satellite, they circle the Earth twice a day. The satellite constellation, it is designed to allow the 24-hour global user navigation and the time determination capability. And each satellite, they contain several high precision atomic clocks and they constantly transmit the radio signal using a unique identifying code. The United States is committed to maintain the availability of at least 24 operational GPS satellites 95% of the time, and to ensure this commitment, the Space Force they normally flies more than 24 GPS satellites to maintain the coverage whenever the baseline satellites are serviced or decommissioned. And the US Space Force has been flying 31 operational GPS satellites for well over a decade. And the extra satellite which are there, they provide the increase in the GPS performance, but they are not considered the part of the core constellation. And in June 2011, the Air Force successfully completed a GPS constellation expansion, which is known as Expendable 24 configuration. So here, 3 of the 24 slots were expanded and 6 satellites were repositioned. So now the GPS, it effectively operates as a 27 slot constellation with improved coverage in most part of the world. So earlier it was 24 slot constellation, but now it is 27 slot constellation. Next is the control segment, which consists of the global network of the ground facilities that track the GPS satellites, monitor their transmission, perform the analysis and send commands and the data to the constellation. The operational control segment, it includes a master control station, then alternate master control station, Air Force Satellite Control Network remote tracking station, ground antenna, Air Force Monitor Station, then National Geospatial Intelligence Agency Monitor Stations. So we have different stations at different locations and each of the station they have different functions. Here we have the compilation of the functions for each of the stations. So monitor station, they track the GPS satellite as they pass overhead. They collect the navigation signal, range or the carrier measurements and the atmospheric data. They feed the observation to the master control station. At the monitor station, sophisticated GPS receivers are utilized so that they can have the better accuracy and they provide the global coverage via 16 sites, 6 from the Air Force plus 10 from the National Geospatial Intelligence Agency. Then we have the master control station which provide the command and control of the GPS constellation. They uses the global monitor station data to compute the precise locations of the satellites and they generate the navigation messages for upload to the satellite and they monitor the satellite broadcast and the system integrity to ensure the constellation health and the accuracy. They also perform the satellite maintenance and the anomaly resolution, including the repositioning of the satellite to maintain the optimal constellation. Then we have the ground antennas which send the commands, navigation data upload and the processor program loads to the satellite. They collect the telemetry data, that is the data from various other ground antennas. They communicate via S-band S-band is the part of the microwave band of the electromagnetic spectrum which cover the frequencies from 2 to 4 gigahertz. And these ground antennas, they perform the S-band ranging to provide anomaly resolution and early orbit support. And they consist of 4 dedicated GPS ground antenna plus 7 Air Force satellite control network remote tracking stations. And last is the user segment, which include the receivers that process the navigation signal from the GPS satellite and calculate the position and time. In today's world, GPS is an essential element of the global information infrastructure, and there are five main uses of the GPS. First, to determine a position, that comes under the location. Then we have the navigation, which is getting from one location to another. Then tracking, that is the monitoring the object or the personal movement. Then we have the mapping, which includes creating the maps of the world. And last is the timing, that is making it possible to make the precise time measurements. These are the references from where the content of the today's video have been taken. Most of the content have been taken from the official website of the GPS, that is www.gps.gov, and the link of all these citations have also been mentioned in the description box. In the next video, we will learn the working principle of the GPS, and after understanding this concept, we will learn the difference between the real-time kinematic and the differential GPS. Thank you for your continuous support. We will meet soon in the next video. Thank you.